Hello students, our today's reaction is carbylamine reaction. This is one important reaction of aliphatic as well as aromatic primary amines. Remember here primary amine, whether it is aliphatic or it is aromatic, when reacts with chloroform in presence of an alcoholic KOH, here slight warming is required, we obtains isocyanide is obtained. If it is aliphatic amine, we will get alkyl isocyanide. If it is aromatic amine, primary amine, we will get aryl isocyanide, or this isocyanide is also known as carbylamine, and this one is having a very unpleasant smell, and that's why this reaction can be used as a test for distinguishing the primary amine from the secondary and tertiary amine. See, we'll discuss here how to write the reaction. See, let it is your aliphatic primary amine, and when it is treated with chloroform in presence of an alcoholic alkali and warmed, this one is alcoholic KOH. See here, these two hydrogens which are linked over the nitrogen, that is the third most electronegative atom. So these two hydrogens are having slight electropositive charge, or we can say that these two hydrogens are active hydrogens, means they have tendency to come out as H+. Now, although we know that the CH bond is non-polar, it is supposed to be non-polar, but here the carbon is linked with the chlorine. Chlorine is having comparatively higher electronegativity than carbon. So here the shared pair of each CCl bond remains displaced away from the carbon and towards the chlorine. So that's why due to the polar nature of CCl bond, the CH bond gets polarized, means the shared pair, this shared pair remains displaced towards the carbon, and this hydrogen becomes also electropositive. So here now total we are having 1, 2, 3 electropositive hydrogens. So in order to remove the electropositive hydrogens, we need the 3 OH minus ion. That's why 3 KOH molecules are taken here. Now these 3 OH minus sets free by the alcoholic KOH removes or abstracts these 3 electropositive hydrogens in the form of 3 water molecules. Now what will happen? The remaining 3 K plus here will come out with these 3 Cl minus in the form of 3 KCl. Now what's left here? It is R and N. Now nitrogen will form bond with the carbon, and we will get here alkyl isocyanide, that is a carbylamine, and this one is having very unpleasant smell, and that's why This reaction is used as a test for separating the primary amine from the secondary and tertiary, and thus the reaction is also known as isocyanide test. Is it clear? See, if we are taking here the aromatic amines, I am taking here, this time it is the aniline. Here it was alkyl, or sorry, it is aliphatic primary amine. This time aniline is taken here. Now when it is warmed with the chloroform in presence of alcoholic KOH, see here, as there are 3 electropositive hydrogens, so 3 KOH molecules will be required. Here warming is also required. So these 3 electropositive hydrogen or active hydrogen comes out with the OH minus in the form of water. Now these 3 Cl minus will comes out with the K plus in the form of 3 KCl, and now the remaining nitrogen and carbon will form bond, and we will get here phenyl isocyanide or carbylamine. This one is amine. This one also has very unpleasant smell. Remember here that the secondary and tertiary amine does not undergo this reaction. Only and only primary amine undergoes this reaction, and that's why this reaction can be used as test for separating or for distinguishing the primary amine from the secondary and tertiary. Now after this, we'll discuss what's the mechanism of this reaction. See, let's see here what happens. We are taking an alkali, and this one is alcoholic KOH. This one dissociates, forming what? K plus and OH minus. Means in the medium there will be a potassium and hydroxide ion will be there. Here it is chloroform. See, basically what happens here, first of all, the dehydrohallogenation means removal of hydrogen and halogen occurs at chloroform molecules. So dehydrohalogenation of chloroform takes place. See, and as we know, for the purpose of dehydrohalogenation, alcoholic KOH is taken. So this is the alcoholic KOH. Now here what happens? The chloroform molecule, although we know the CH bond is the non-polar, the shared pair of electron is supposed to lie at a center. Okay, but due to the presence of 3 electron withdrawing Cl over the same carbon, this carbon gets slightly electropositive, and as a result the shared pair of electron, this one, remains tilted towards the carbon, and the CH bond, which was expected to be non-polar, gets polarized. And now in order to remove this H as in the form of H plus. Here alkali OH minus is required, and that's why alcoholic KOH is taken. Now what happens? Under the influence of this OH minus, the shared pair of electron of the CH bond completely shifted over the carbon, and the H comes out as H plus, combines to this OH minus, forming H2O. Now here the remaining species is carbon. Over this there are 3 Cl, and as the 2 electrons comes over this carbon, so this carbon will get negatively charged. See what happens here? The K plus are still in the cell medium. So under the influence of this K plus, see, this CCl bond is polar bond. One of the Cl comes out along with the electron pair of CCl bond. We knows that the halogens are better leaving group. So this Cl sets free as Cl minus, combines to this K plus in the form of KCl. As here in these 2 electrons, 1 electron was of the carbon. So as carbon is losing its 1 electron, so carbon will become positive charged, and already it is having a negative. So that's why positive negative charge will get neutralized, and we will get here this type of species where carbon is bivalent and is having a 6 electron. Means we will get a carbene as intermediate. The name of this carbene is dichloromethylene, is obtained as a intermediate. So remember here in the carbylamine reaction, carbene is obtained as, or is formed, it's better, is formed as intermediate. Now what happens here? This carbene, as it is having only 6 valency electron, so this one is electron deficient, and that's why here this carbene will attack to the primary amine. As in primary amine, the central nitrogen is having a lone pair. So this C, here there are 2 Cl. So this one, carbon of the carbene, is having a 6 valency electrons. See, 2 electrons of this bond, 2 electrons of this bond, and there is a pair of electron all present over the carbon. So in this way, this carbene is having in carbene, the carbon is having 6 valence electron. Now in order to compensate its deficiency of electron, nitrogen will donate its electron pair to the carbon, because nitrogen is having a lone pair. So this amine, primary amine, is acting as a Lewis base. So what will happen here? Rn. Now at this nitrogen there are 2 hydrogens. Since nitrogen has donated electron pair to the carbon, so bond will form in between the nitrogen and carbon, and at this carbon there are 2 Cl. See, 1 pair of electron was already present over the carbon, and this nitrogen also has donated electron pair to the carbon. So carbon will become electron rich and will acquire now negative charge. And as the nitrogen has donated electron pair, so will become electron deficient and will get a positive charge. Is it clear? Thereafter what happens? In order to compensate the positive charge of the nitrogen, the electron pair of one of the NH bond shifted over the nitrogen. The H plus will set free, and that H plus will form bond with the negatively charged carbon, and we will get R, N. Here there's the electron pair, this nitrogen will form, one hydrogen is there already, C, and at this carbon there were 2 Cl. The H plus sets free from here, from nitrogen, forms bond with the carbon, and we will get this type of structure. Now since as we are taking in the medium already, alkali alcoholic KOH is taken here. Now what happens here? Here the hydrogen is linked over the third most electronegative nitrogen, means this hydrogen is having a electropositive character. Here what happens, one of the Cl of C comes out, along with it the electron pair of CCl bond in the form of Cl minus. As a result, this carbon will become positively charged. In order to compensate the positive charge of the carbon, the electron pair of this NH bond shifted in between the nitrogen and carbon. Now the Cl minus combines to the K plus and sets free as KCl, and the H plus comes out with the OH minus in the form of water, and here we will get Rn. Now as the electron pair shifted of NH bond shifted in between the N and C, double bond will form here, and over this carbon now there will be one hydrogen and one chlorine. Is it clear? Again, in the medium there is an alkali, KOH is here. Now there's a difference in the electronegativities of the carbon and chlorine. So what happens here? The second CCl bond breaking occurs, heterolytic bond breaking. The Cl minus will set free, combines to the K plus in the form of KCl. Now the carbon will become like on deficient because carbon has lost its electron. So in order to compensate the deficiency of the carbon, the electron pair of the CH bond will completely shifted over the carbon, and the H plus will set free. That H plus will combine to the OH minus, comes out in the form of water. Now here what will happen? Here it is Rn. Nitrogen is having a one lone pair. There's a double bond between the nitrogen and carbon, and these two electrons of the carbon comes over the NH-CH bond comes over the carbon. This type of species we will get. See, by the as here carbon is losing one of its electron, will acquire positive charge, and the positive charge will be compensated by these two electrons. So this carbon will not have any charge here. Now this carbon at present is having how many electrons? Valence electron 2 plus 2 electrons of this bond and 2 electrons of this bond. So total it is having a 6 electrons. So in order to compensate or complete its octet, the nitrogen will donate its electron pair here, means will form a coordinate bond with the carbon, and you will get here there was a double bond with this carbon, and nitrogen has donated its electron pair to the carbon. Already one lone pair was here. Now as you know, once the coordinate bond is formed, so after that one cannot make a difference between the normal covalent bond and coordinate bond. Yes, only one difference is that this bond is having a slight polarity. So you will get this type of structure. Here there will be a resonance. These are the resonating structures. Okay, and this one is our final product, means alkyl isocyanide. So in this way we obtain the alkyl isocyanide. Either you may write the isocyanide in this manner, or You may write here, this is alkyl isocyanide is obtained as a end product. Is it clear?